Language and Mind, Chomsky, Part 2 of 5, Linguistic Contributions to the Study of Mind. Part 2. In discussing the past, I refer to two major traditions that have enriched the study of language in their separate and very different ways. And in my last lecture, I tried to give some indication of the topics that seem on the immediate horizon today as a kind of synthesis of philosophical grammar and structural linguistics that are beginning to take shape. Each of the major traditions of study and speculation that I have been using as a point of reference was associated with a certain characteristic approach to the problems of mind. We might say without distortion that each evolved as a specific branch of the psychology of its time to which it made a distinctive contribution. It may seem a bit paradoxical to speak of structural linguistics in this way, given its militant anti-psychologism, but the paradox is lessened when we take note of the fact that this militant anti-psychologism is no less true of much of contemporary psychology itself, particularly of those branches that, until a few years ago, monopolized the study of use and acquisition of language. We live, after all, in the age of behavioral science, not of the science of mind. I do not want to read too much into a terminological innovation, but I think that there is some significance in the ease and willingness with which modern thinking about man and society accepts the designation behavioral science. No sane person has ever doubted that behavior provides much of the evidence for this study, all of the evidence if we interpret behavior in a sufficiently loose sense. But the term behavioral science suggests a not-so-subtle shift of emphasis towards the evidence itself and away from the deeper underlying principles and abstract mental structures that might be illuminated by the evidence of behavior. It is as if natural science were to be designated the science of meter readings. What in fact would we expect of natural science in a culture that was satisfied to accept this designation for its activities? Behavioral science has been much preoccupied with data and organization of data, and it has even seen itself as a kind of technology of control of behavior. Anti-mentalism in linguistics and in philosophy of language conforms to this shift of orientation. As I mentioned in my first lecture, I think that one major indirect contribution of modern structural linguistics results from its success in making explicit the assumptions of an anti-mentalistic, thoroughly operational and behaviorist approach to the phenomena of language. By extending this approach to its natural limits, it laid the groundwork for a fairly conclusive demonstration of the inadequacy of any such approach to the problems of mind. More generally, I think that the long-range significance of the study of language lies in the fact that in this study it is possible to give a relatively sharp and clear formulation of some of the central questions of psychology and to bring a mass of evidence to bear on them. What is more, the study of language is, for the moment, unique in the combination it affords of richness of data and susceptibility to sharp formulation of basic issues. It would, of course, be silly to try to predict the future of research, and it will be understood that I do not intend the subtitle of this lecture to be taken very seriously. Nevertheless, it is fair to suppose that the major contribution of the study of language will lie in the understanding it can provide as to the character of mental processes and the structures they form and manipulate. Therefore, instead of speculating on the likely course of research into the problems that are coming into focus today, I will concentrate here on some of the issues that arise when we try to develop the study of linguistic structure as a chapter of human psychology. A number of such problems might be enumerated, for example, the problem of how the intrinsic content of phonetic features determines the functioning of phonological rules and the role of universal forms, formal conditions in restricting the choice of grammars and the empirical interpretation of such grammars, the relations of syntactic and semantic structure, the nature of universal semantics, performance models that incorporate generative grammars, and so on. It is quite natural to expect that a concern for language will remain central to the study of human nature, as it has been in the past. Anyone concerned with the study of human nature and human capacities must somehow come to grips with the fact that all normal humans acquire language, whereas acquisition of even its barest rudiments is quite beyond the capacities of an otherwise intelligent ape, a fact that was emphasized quite correctly in Cartesian philosophy. Modern attempts to train apes in behavior that the investigators regard as language-like confirm this incapacity, though it may be that the failures are to be attributed to the technique of operant conditioning and therefore show little about the animal's actual abilities. See, for example, the report by C.B. Forster, Arithmetic Behavior in Chimpanzees in Scientific American. Forster attempted to teach chimpanzees to match the binary numbers to sets of 1 to 7 objects. He reports that hundreds of thousands of trials were required for 95% accuracy to be achieved, even in this trivial task. Of course, even at this stage, the apes had not learned the principle of binary arithmetic. They would not, for example, be able to match a 4-digit binary number correctly, and presumably they would have done just as badly in the experiment had it involved an arbitrary association of the binary numbers to sets rather than the association determined by the principle of the binary notation. Forster overlooks this crucial point and therefore concludes mistakenly that he has taught the rudiments of symbolic behavior. The confusion is compounded by his definition of language as, quote, a set of symbolic stimuli that control behavior, and by his strange belief that the effectiveness of language arises from the fact that utterances control almost identical performances in speaker and listener. It is widely thought that the extensive modern studies of animal communication challenge this classical view, and it is almost universally taken for granted that there exists a problem of explaining the evolution of human language from systems of animal communication. However, a careful look at recent studies of animal communication seems to me to provide little support for these assumptions. Rather, these studies simply bring out even more clearly the extent to which human language appears to be a unique phenomenon without significant analog in the animal world. If this is so, it is quite senseless to raise the problem of explaining the evolution of human language from more primitive systems of communication that appear at lower levels of intellectual capacity. The issue is important, and I would like to dwell on it for a moment. The assumption that human language and the invention thereof evolved from more primitive systems is developed in an interesting way by Karl Popper in his recently published Arthur Compton lecture, Clouds and Clocks. He tries to show how problems of freedom of will and Cartesian dualism can be solved by the analysis of this evolution. I am not concerned now with the philosophical conclusions that he draws from this analysis, but with the basic assumption that there is an evolutionary development of language from simpler systems of the sort that one discovers in other organisms. Popper argues that the evolution of language passed through several stages, in particular a lower stage in which vocal gestures are used for expression of emotional state, for example, and a higher stage in which articulated sound is used for expression of thought, in Popper's terms, for description and critical argument. His discussion of stages of evolution of language suggests a kind of continuity, but in fact he establishes no relation between the lower and higher stages, and does not suggest a mechanism whereby transition can take place from one stage to the next. In short, he gives no argument to show that the stages belong to a single evolutionary process. In fact, it is difficult to see what links these stages at all, except for the metaphorical use of the term language. There is no reason to suppose that the gaps are bridgeable. There is no more of a basis for assuming an evolutionary development of higher from lower stages, in this case, than there is for assuming an evolutionary development from breathing to walking. The stages have no significant analogy, it appears, and seems to involve entirely different processes and principles. A more explicit discussion of the relation between human language and animal communication systems appears in a recent discussion by the comparative ethologist W. H. Thorpe. See W. H. Thorpe, Animal Vocalization and Communication, and F. L. Darley, edited, Brain Mechanisms Underlying Speech and Languages. He points out that mammals other than humans appear to lack the human ability to imitate sounds, and that one might therefore have expected birds, many of which have this ability to a remarkable extent, to be the group which ought to have been able to evolve language in the true sense and not the mammals. Thorpe does not suggest that human language evolved in any strict sense from simpler systems, but he does argue that the characteristic properties of human language can be found in animal communication systems, although we cannot at the moment say definitely that they are all present in one particular animal. The characteristics shared by human and animal language are the properties of being purposive, syntactic, and propositional. Language is purposive in that there is nearly always in human speech a definite intention of getting something over to somebody else, altering his behavior, his thoughts, or general attitude toward a situation. Human language is syntactic in that an utterance is a performance with an internal organization, with structure and coherence. It is propositional in that it transmits information. In this sense, then, both human language and animal communication are purposive, syntactic, and propositional. All this may be true, but it establishes very little, since when we move to the level of abstraction at which human language and animal communication fall together, almost all other behavior is included as well. Consider walking. Clearly, walking is purposive behavior in the most general sense of purposive. Walking is also syntactic in the sense just defined, as in fact Carl Lashley pointed out a long time ago in his important discussion of serial order and behavior, to which I referred in the first lecture. See K.S. Lashley, The Problem of Serial Order and Behavior in Cerebral Mechanisms in Behavior. Furthermore, it can certainly be informative. For example, I can signal my interest in reaching a certain goal by the speed or intensity with which I talk or walk. It is, incidentally, precisely in this manner that the examples of animal communication that Thorpe presents are propositional. He cites as an example the song of the European robin, in which the rate of alternation of high and low-pitched signals the intention of the bird to defend its territory. The higher the rate of alternation, the greater the intention to defend the territory. The example is interesting, but it seems to me to show very clearly the hopelessness of the attempt to relate human language to animal communication. Every animal communication system that is currently known, if we disregard some science fiction about dolphins, uses one of two basic principles. Either it consists of a fixed, finite number of signals, each associated with a specific range of behavior or emotional state, as is illustrated in the extensive primate studies that have been carried out by Japanese scientists for the past several years, or it makes use of a fixed finite number of linguistic dimensions, each of which is associated with a particular non-linguistic dimension, in such a way that selections of a point along the linguistic dimension determines and signals a certain point along the associated non-linguistic dimension. The later is the principle realized in Thorpe's birdsong example. Rate of alternation of high and low pitch is a linguistic dimension correlated with the non-linguistic dimension of intention to defend a territory. The bird signals its intention to defend a territory by selecting a correlated point along the linguistic dimension of pitch alternation. I use the word select loosely, of course. The linguistic dimension is abstract, but the principle is clear. A communication system of the second type has an indefinitely large range of potential signals, as does human language. The mechanism and principle, however, are entirely different from those employed by human language to express indefinitely many new thoughts, intentions, feelings, and so on. It is not correct to speak of a deficiency of the animal system in terms of range of potential signals, rather the opposite, since the animal system admits in principle of continuous variation along the linguistic dimension, insofar as it makes sense to speak of continuity in such a case, whereas human language is discrete. Hence the issue is not one of more or less, but rather of an entirely different principle of organization. When I make some arbitrary statement in a human language, say that the rise of supranational corporations poses new dangers for human freedom, I am not selecting a point along some linguistic dimension that signals a corresponding point along an associated non-linguistic dimension, nor am I selecting a signal from a finite behavioral repertoire, innate or learned. Furthermore, it is wrong to think of human use of language as characteristically informative in fact or in intention. Human language can be used to inform or to mislead, to clarify one's own thoughts, or to display one's cleverness, or just simply for play. If I speak with no concern for modifying your behavior or thoughts, I am not using language any less than if I say exactly the same things with such intention. If we hope to understand human language and the psychological capacities on which it rests, we must first ask what it is, not how or for what purposes it is used. When we ask what human language is, we find no striking similarity to animal communication systems. There is nothing useful to be said about behavior or thought at the level of abstraction at which animal and human communication fall together. The examples of animal communication that have been examined to our present date do share many of the properties of human gestural systems, and it might be reasonable to explore the possibility of direct connection in this case. But human language and its invention, it appears, is based on entirely different principles. This, I think, is an important point, often overlooked by those who approach human language as a natural, biological phenomenon. In particular, it seems rather pointless, for these reasons, to speculate about the evolution of human language from simpler systems, perhaps as absurd as it would be to speculate about the evolution of atoms from clouds of elementary particles. As far as we know, possession of human language is associated with a specific type of mental organization, not simply a higher degree of intelligence. There seems to be no substance to the view that human language is simply a more complexified instance of something to be found elsewhere in the animal kingdom. This poses a problem for the biologist, since if true, it is an example of true emergence, the appearance of a qualitatively different phenomenon at a specific stage of complexity of organization. Recognition of this fact, though formulated in entirely different terms, is what motivated much of the classical study of language by those whose primary concern was the nature of mind. And it seems to me that today there is no better or more promising way to explore the essential and distinctive properties of human intelligence than through the detailed investigation of the structure of this unique human possession. A reasonable guess, then, is that if empirically adequate generative grammars can be constructed and the universal principles that govern their structure and organization determined, then this will be an important contribution to human psychology in ways to which I will turn directly in detail. In the course of these lectures, I have mentioned some of the classical ideas regarding language structure and contemporary efforts to deepen and extend them. It seems clear that we must regard linguistic competence, knowledge of a language, as an abstract system underlying behavior, a system constituted by rules that interact to determine the form and intrinsic meaning of a potentially infinite number of sentences. Such a system, a generative grammar, provides an explication of the Humboldtian idea of form of language, which in an obscure but suggestive remark in his great posthumous work Über die Verschiedenheit des menschlichen Sprachgebrauchs, Humboldt defines as that constant and unvarying system of processes underlying the mental act of raising articulated, structurally organized signals to an expression of thought. Such a grammar defines a language in the Humboldtian sense, namely as a recursively generated system where the laws of generation are fixed and invariant, but the scope and the specific manner in which they are applied remain entirely unspecified. In each such grammar, there are particular idiosyncratic elements, selection of which determines one specific human language, and there are general universal elements, conditions on the form and organization of any human language, that form of the subject matter for the study of universal grammar. Among the principles of universal grammar are those that I discussed in the preceding lecture, for example, the principles that distinguish deep and surface structure, and that constrain the class of transformational operations that relate them. Notice, incidentally, that the existence of definite principles of universal grammar makes possible the rise of a new field of mathematical linguistics, a field that submits to abstract study the class of generative systems meeting the conditions set forth in universal grammar. This inquiry aims to elaborate the formal properties of any possible human language. The field is in its infancy. It is only in the last decade that the possibility of such an enterprise has been envisioned. It has some promising initial results, and it suggests one possible direction for future research that might prove to be of great importance in its novelty. Thus, mathematical linguistics seems for the moment to be in a uniquely favorable position among mathematical approaches in the social and psychological sciences to develop not simply as a theory of data, but as the study of highly abstract principles and structures that determine the character of human mental processes. In this case, the mental processes in question are those involved in the organization of one specific domain of human knowledge, namely, knowledge of language. The theory of generative grammar, both particular and universal, points to a conceptual lacuna in psychological theory that I believe is worth mentioning. Psychology, conceived as behavioral science, has been concerned with behavior and acquisition or control of behavior. It has no concept corresponding to competence, in the sense in which competence is characterized by a generative grammar. The theory of learning has limited itself to a narrow and surely inadequate concept of what is learned, namely, a system of stimulus-response SR connections, a network of associations, a repertoire of behavioral items, a habit hierarchy, or a system of dispositions to respond in a particular way under specifiable stimulus conditions. This limitation is revealed, for example, in such statements as this from W.M. Weist in recent criticisms of behaviorism and learning in Psychological Bulletin. An empirical demonstration that a child has learned the rules of grammar would be his or her exhibiting the verbal performance called uttering the rules of grammar. That this performance is not usually acquired without special training is attested to by many grammar school teachers. One may even speak quite grammatically without having literally learned the rules of grammar. Weist's inability to conceive of another sense in which the child may be said to have learned the rules of grammar testifies to the conceptual gap that we are discussing. Since he refuses to consider the question of what is learned, and to clarify this notion before asking how it is learned, he can only conceive of grammar as the behavioral regularities in the understanding and production of speech, a characterization that is perfectly empty as it stands, there being no behavioral regularities associated with, let alone in, the understanding and production of speech. One cannot quarrel with the desire of some investigators to study the acquisition and maintenance of actual occurrences of verbal behavior. It remains to be demonstrated that this study has something to do with the study of language. As of now, I see no indication that this claim can be substantiated. Insofar as behavioral psychology has been applied to education or therapy, it has correspondingly limited itself to this concept of what is learned. But a generative grammar cannot be characterized in these terms. What is necessary in addition to the concept of behavior and learning is a concept of what is learned, a notion of competence that lies beyond the conceptual limits of behaviorist psychological theory. Like much of modern linguistics and modern philosophy of language, behaviorist psychology has quite consciously accepted methodological restrictions that do not permit the study of systems of the necessary complexity and abstractness. See the paper by Chomsky, Some Empirical Assumptions in Modern Philosophy of Language, in Essays in Honor of Ernest Nagel. See also for a discussion of the work of Quine and Wittgenstein from this point of view. One important future contribution of the study of language to general psychology may be to focus attention on this conceptual gap and to demonstrate how it may be filled by the elaboration of a system of underlying competence in one domain of human intelligence. There is an obvious sense in which any aspect of psychology is based ultimately on the observation of behavior, but it is not at all obvious that the study of learning should proceed directly to the investigation of factors that control behavior or of conditions under which a behavioral repertoire is established. It is first necessary to determine the significant characteristics of this behavioral repertoire, the principles on which it is organized. A meaningful study of learning can proceed only after this preliminary task has been carried out and has led to a reasonably well-confirmed theory of underlying competence. In the case of language, to the formulation of the generative grammar that underlies the observed use of language. Such a study will concern itself with the relation between the data available to the organism and the competence that it acquires. Only to the extent that the abstraction to competence has been successful, in the case of language to the extent that the postulated grammar is descriptively adequate in the sense described earlier, can the investigation of learning hope to achieve meaningful results. If in some domain the organization of the behavioral repertoire is quite trivial and elementary, then there will be little harm in avoiding the intermediate stage of theory construction, in which we attempt to characterize accurately the competence that is acquired. But one cannot count on this being the case, and in the study of language it surely is not the case. With a richer and more adequate characterization of what is learned, of the underlying competence that constitutes the final state of the organism being studied, it may be possible to approach the task of constructing a theory of learning that will be much less restricted in scope than modern behavioral psychology has proved to be. Surely it is pointless to accept methodological strictures that preclude such an approach to problems of learning. Are there other areas of human competence where one might hope to develop a fruitful theory, analogous to generative grammar? Although this is a very important question, there is very little that can be said about it now. One might, for example, consider the problem of how a person comes to acquire a certain concept of three-dimensional space, or an implicit theory of human action in similar terms. Such a study would begin with the attempt to characterize the implicit theory that underlies actual performance, and would then turn to the question of how this theory develops under the given conditions of time and access to data. That is, in what way the resulting system of beliefs is determined by the interplay of available data, heuristic procedures, and the innate schematism that restricts and conditions the form of the acquired system. At the moment, this is nothing more than a sketch of a program of research. There have been some attempts to study the structure of other language-like systems. The study of kinship systems and folk taxonomies comes to mind, for example, but so far at least nothing has been discovered that is even roughly comparable to language in these domains. No one, to my knowledge, has devoted more thought to this problem than Levi Strauss. For example, his recent book on the categories of primitive mentality is a serious and thoughtful attempt to come to grips with this problem. Nevertheless, I do not see what conclusions can be reached from a study of his materials beyond the fact that the savage mind attempts to impose some organization on the physical world, that humans classify if they perform any mental acts at all. Specifically, Levi Strauss's well-known critique of totemism seems to reduce to little more than this conclusion. In the next talk, we will talk about Levi Strauss's models and his investigations and how they quite consciously work in terms of structural linguistics.